Welcome back to Bahamian Mathematics. Please make sure to like, subscribe, and share to see more videos like this one. In today's video, we will be calculating the volume of a cube or a cuboid. We will see that volume equals length times width times height. So first, what is a cube though? A cube, we say, is a three-dimensional solid object which has 6 square faces, 1 on the top, 2 on the bottom, 3 on the left, 4 on the right, and 5 at the back, 6 at the front. There are 6 square faces. It has 8 vertices, and vertices is just the plural of a vertex. And so here's a vertex, here's a vertex, here's another one. That's number 4, 5, 6, 7, and in the back is 8. We call them the corners. They are the pointed parts where the two edges meet. And it has 12 edges. And let's count them now. In yellow, 1, 2, 3, 4 at the top. At the bottom, 5, 6, 7, 8. And now going up and down, 9, 10, 11, 12. There are 12 edges. And all of the sides of a cube are the same length. If one side is 3 centimeters, then they all will be 3 centimeters. This is also known as a regular hexahedron, and it is one of the 5 Platonic solids that you may learn about. Here they are listed: the 5 Platonic solids, the tetrahedron, the hexahedron, we know it as a cube, the octahedron, the dodecahedron, and the icosahedron. Let's imagine that we had a cube and we were filling it up with water, and we wanted to know how much water could it hold. And if we filled it up to a certain point, this would be known as the volume of water that we have put inside of the cube. And so the volume is stated as the capacity occupied by a 3-dimensional solid shape. Here's its length, here's its width, and here is the height. And so the number of cubes that it takes to completely fill the inside of a 3-dimensional shape is its volume. We use capacity when we talk about liquids filling up a container. If we took little cubes and we put them inside of this big cubes, the number of cubes that it took to fill it is its volume. So let's imagine we had a faucet and we were putting cubes inside of this big cube that were 1 centimeter by 1 centimeter by 1 centimeter. And we started putting them next to each other side by side inside of the big cube. We would find out eventually how many of those it took to fill it. Instead of doing that, we can use the formula length times width times height. And so if we imagine in this cube, the length is 5, the width is 5, and the height is 5, all we have to do is multiply 5 times 5 times 5. 5 times 5 is 25, times 5 again gives us 125 centimeters cubed. Every time we talk about volume, we have to state it as cubed units. So let's take a look at how this works. You're familiar with area, in which we had a flat object which had a length and a width, and we multiplied the length and the width to give us the area, and it was in squared units. So imagine if we took this object and we found the area, we would multiply length by width. But if we started to stack similar objects on top of each other, we can see now that we are accumulating something that looks like this, that has a height. And when we do this, we are turning that flat shape now into a 3-dimensional shape that now has a height, a length, and a width. And this is now how we get the volume formula. It has a length and a width, but now also a height. And so the formula for volume of a cube is length times width times height. Now let's take a look at this shape, which looks similar to the cube, but you can see that there are some sides that are longer than others. This is known as a cuboid. It's a 3-dimensional solid object as well. It has 6 rectangular faces. Here's 1 at the top, 2 is at the bottom, 3 is on the left, 4 is at the right, 5 is at the back, 6 is at the front. Those are the 6 rectangular faces. It has 8 vertices as well. Remember, vertices, plural of vertex, and they are the corners. And so 1, 2, 3, 4. And at the bottom, 5, 6, 7, 8 vertices. And it has 12 edges, just like a cube does. 1, 2, 3, 4, 5, 6, 7, 8 on the bottom. And now up and down, 9, 10, 11, 12. 12 edges. The sides, however, are different lengths. In this case, one side is 10 centimeters, one side is 7 centimeters, and one side is 8 centimeters. But how much can a cuboid hold? Well, it's similar to filling it up, again, with water. And we would say, how much water is in the cuboid? How much water can it contain? What is its capacity? But we're not filling it up with water. We imagine that we're filling it up, again, with cubes. And so the volume, again, is the capacity occupied by a three-dimensional solid object. This has a length, a width, and a height. And the volume is the number of cubes it takes to completely fill the inside of this three-dimensional shape. And so if we started to pour or place 1 centimeter, 1 centimeter, 1 centimeter cubes inside of the cuboid, we will end up determining how many of those it takes to completely fill it. But that takes a lot of time, and so instead we will use the volume formula: length times width times height. And in this case, we have a 10 centimeter length, a 4 centimeter width, and a 6 centimeter height. 10 times 4 is 40, times 6 is 240 centimeters cubed. Again, we use the raised 3 to mean cube because volume is always stated in cubed units. And so let's calculate the volume of this particular cube. You can see that there is a length of 3 meters. But there are no other lengths listed. We know, though, that a cube has every side the same length. And so the formula we will use is length times width times height. And if the length is 3, then the width is 3 and the height is 3. So 3 times 3 times 3, which we can state as 3 cubed. And we know that 3 times 3 is 9. 9 times 3 is 27 meters cubed. Remember, the 3 is cubed units. Now let's look at this cube. It has a width of 10 inches. Again, the volume formula is length times width times height. And we only need to be given one side of a cube to know all of the sides are the same length. So 10 times 10 times 10, it can be written as 10 cubed. And we know 10 times 10 is 100. And 100 times 10, we add another 0 to make 1,000 inches cubed. Let's take a look at this cuboid. The formula for a cuboid, again, is length times width times height. The length of this cuboid is 2 kilometers, multiplied by the width of 0.5, multiplied by the height of 1. Well, we know 2 times half of 2 is 1, times 1 gives us 1. So the volume is 1 kilometer cubed. And now it's quiz time. Is the following shape a cube or a cuboid? You have 5 seconds. The answer is a cuboid. Because not all of the sides are the same length, you have some sides 7 millimeters but one side 6, it can't be a cube and therefore it is a cuboid. The measurements are different. Find the volume of the cube. Did you get it? The answer is 64 kilometers cubed. How did we do that? If it's a cube, each side is 4 kilometers, so 4 times 4 times 4, length times width times height, gives us 4 times 4 is 16, times 4 again gives us 64. Question 3. Find the volume of the cuboid. Time's up. Volume equals length times width times height, and if you multiplied 4 by 3 by 2, you get 24 meters cubed. And question 4. Find the volume of the cube. Time's up. The answer is 8 meters cubed. If it is a cube, every side is the same length. 2 times 2 times 2. 2 times 2 is 4 times 2 gives us 8. And now you've solved the mystery of how to calculate the volume of a cube and a cuboid. Great job.